Questions 6 through 11. Listen to part of a discussion in an oceanography class. The class is studying hydrothermal vents.
All right, let's get started by briefly going over the mid-ocean ridge system, the underwater mountain chain that winds its way around the globe. What do we know about the mid-ocean ridge? Lindsay?
Well, we know that it's a nearly continuous zone of spreading seafloor where two tectonic plates are pulling apart.
And when two plates pull apart, there are places where magma breaks through the mantle. And when magma comes close to the seafloor, it heats up the water and the surrounding rock.
Yes, that's true. Good points. Okay, so we have spreading zones where molten material below the seafloor heats the water. We can think of a spreading zone as sort of a linear volcano with vent holes at various points along the ridge. At these hydrothermal vents, plumes of mineral-rich superheated water erupt from fissures in the seafloor. Okay, in an active vent field, the temperature of the water can range from 25 to 400 degrees Celsius. Some hydrothermal vents form cylindrical chimneys, which are sort of smokestacks formed from dissolved minerals in the superheated vent water. When the superheated vent water contacts the near-freezing seawater, the minerals precipitate out to form particles. These mineral particles then add to the height of the stacks. Some of these chimney structures can reach heights of 60 meters. Yes, Nate?
So, you could say a hydrothermal vent is like a geyser, but on the seafloor, right? I mean, I've seen a lot of geysers, and some of them look like chimneys.
Exactly. A hydrothermal vent is an underwater geyser. Most of them are found at an average depth of, about 2,100 meters below the surface, and some are as deep as 2,500 meters. As you can imagine, the pressure is very intense at these depths. The pressure causes the water to remain a superheated liquid, and the circulation of water through hydrothermal vents plays a major role in the ocean's chemistry and heat flow. As superheated water circulates through the vents, it interacts chemically with the underlying magma. This causes the seawater to lose magnesium and gain calcium, which explains the lack of magnesium and the abundance of calcium in the sea.
So, at those kinds of depths, and it being so dark, and with superheated water up to 400 degrees, how can anything live there?
The area around a deep sea vent might seem dark and inhospitable to life, but these zones are actually host to an amazing array of marine organisms. Some of these organisms can survive in or near water as hot as molten lead. And because organisms living in the deep sea have no access to sunlight, they have to depend on nutrients found in the hydrothermal fluids where they live. The water that comes out of hydrothermal vents is rich in dissolved minerals such as sulfur compounds, including hydrogen sulfide.
Hydrogen sulfide. Isn't that sewer gas, and isn't it toxic?
Yes, it is. Hydrogen sulfide is highly toxic to most known organisms. However, certain bacteria at vent sites can transform hydrogen sulfide and other sulfur compounds into organic material through the process of chemosynthesis. Chemosynthesis changes the toxic compounds into a source of food for the bacteria. The chemosynthetic bacteria grow into a thick mat, which this thick mat of bacteria then serves as a food source for other organisms. For example, very tiny crustaceans graze on the bacteria directly. Then, larger organisms, such as snails, shrimp, crabs, tube worms, and small fish, all of these creatures feed on the tinier creatures, and then, in turn, they're eaten by larger fish and octopuses, All of this forming a chain of predator-prey relationships. So you can see that compared to most of the deep sea, the sites around hydrothermal vents are teeming with a diversity of life.
Number 6. Why does the professor say this?
All right, let's get started by briefly going over the mid-ocean ridge system, the underwater mountain chain that winds its way around the globe. What do we know about the mid-ocean ridge?
Number 7. Which of the following are characteristics of a hydrothermal vent zone? Number 8. What causes some hydrothermal vents to have chimney structures? Number 9. According to the discussion, which of the following statements is true? Number 10. Listen again to part of the discussion. Then answer the question.
And because organisms living in the deep sea have no access to sunlight, they have to depend on nutrients found in the hydrothermal fluids where they live. The water that comes out of hydrothermal vents is rich in dissolved minerals such as sulfur compounds, including hydrogen sulfide.
Hydrogen sulfide. Isn't that sewer gas and isn't it toxic?
Why does the student say this?
Hydrogen sulfide. Isn't that sewer gas and isn't it toxic?
Number 11. What occurs during the process of chemosynthesis near hydrothermal vents?